Alright, this will be a very quick revision on waves. This is the worksheet that I gave all the students in the class earlier on. Okay, these are the answers for the first 4 questions. I'm not going to go through one by one, but just a quick note. You need to know the definitions for at least these 4 terms: frequency, period, wavelength, and amplitude. Because if you do not know these definitions, it will be impossible for you to solve question 5. Now, question 5 answer is wrong. I've not tapped in the answer yet. Now, let's go to question 5. What information or informations can be inferred from the above statement? 10 complete waves are produced in 2 seconds. Does this look very familiar to you from above? In fact, this particular information tells us about 2 things: period and frequency. Okay, just give me a moment. Now, okay, let's ignore frequency first. Now, period is defined as the time taken to produce one complete wave. So over here, 10 complete waves are produced in 2 seconds. What about one complete wave? One complete wave is produced in 0.2 seconds. Agree or not? After some calculation. Okay, 0.2 seconds. Do you agree? Right? 10 waves in 2 seconds. So one wave in 0.2 seconds. I can also infer about frequency. Let's ignore period now. Frequency. Frequency is defined as the number of complete waves produced in 1 second. Over here it tells us 10 complete waves in 2 seconds. So we have 5 complete waves produced in 1 second. And that implies our frequency is 5 Hertz. Alright, this is very, very crucial because O-level, and in fact the teachers in the school, when we set papers, we will not directly give you information about frequency. Like for example, frequency is so and so, period is so and so, calculate speed. Now that would be too direct. What we will do on the other hand is to give you information like this. Okay, 10 complete waves produced in 2 seconds. And then you use this information to derive information about frequency and period and use that to calculate something else. Now open up question 6. Question 6. Explain what is meant by a wave having a frequency of 27 Hz. Now same thing again, go back to definition. Frequency of 27 Hz means 27 complete waves are produced in 1 second, because frequency is defined as the number of complete waves produced in 1 second. So if you have 27 Hz, it means you have 27 complete waves produced in 1 second. Now let's look at 2 particular graphs of waves. I mentioned before, when you look at the graph of a wave, the very first thing that you should look at is the axis of the horizontal, the description of the horizontal axis. In this case, the horizontal axis stands for distance, but for the graph below, the horizontal axis stands for time. And depending on the horizontal axis, you can get different information directly. For the first graph, we can only obtain, of course, amplitude and wavelength, the length of one complete wave. In this case, 20 meters will be the wavelength. This is one complete wave. We cannot obtain frequency, we cannot obtain period directly. For the next graph, axis is in time, we can only obtain period. One complete wave takes 0.2 seconds, so the period is 0.2 seconds by definition. Alright, next. Okay, these are the ripples formed when you have a dipper in the middle striking a water surface. You are looking from the top view, and these are the ripples that are formed. Now I asked the rest of the class, what are the names of this line, and this line? and of course the outer ring. What are the names of all these circular lines? They are the wave fronts. Very important. Wave fronts. Now, what is the definition of wave front? You are expected to know, and I'll leave it to you to find out. Right? It's all in the notes. The definition of wave fronts. Okay, so that one I'll leave it to you. What about this? The distance between two wave fronts. For example, this distance. Okay, this distance, or this distance. What do they measure? They measure wavelength. Alright, you have to know this. We'll see one question in a while on how this is being applied. Now, this is an actual O-level question in 2009 in your tennis series. Okay, you see here the picture of a wave pattern. This distance is 20 cm, and they tell you the distance between two crests as shown is 20 cm. Now, wave fronts are formed by wave fronts are formed by crests. So if I use this pen to show you, if you observe a wave from the side, okay, there is a crest, there is a trail, crest and a trail, crest and a trail, and so on. Now this from the side view, but if I look from the three-dimensional, okay, waves are actually formed like this, like tides. Okay, and why not? Okay, that one tide, two tide, and three tides. Now this line that joins all the different crests are known as the wave front. So when you look from the top view, you actually see these lines. Okay, the wave front. So I repeat, this is a wave front, wave front, wave front, and from the top view, you see all these lines. So in fact, I can join out like this. Okay, if you look from the side view, you should be able to see something like this. Alright. Okay, so they tell you the distance between the two crests is 20 cm. Okay, this crest and this crest, 20 cm. Two crests, 20 cm. Isn't that the wavelength? Two crests what? Two crests, 20 cm. Wavelength lah. But how many crests away are they apart? One crest, two crests, three crests, four crests, five crests away. This 20 cm refers to 5 times of the wavelength. So the wavelength here is in fact 4 centimeters. And hence the speed of the wave, V equals to F lambda, would be equals to frequency given 4 Hertz over here times wavelength 4. Answer is 16 cm per second. Lastly, we look at a picture like this of wave fronts that show different wavelengths. Okay, in this case, the wavelength is increasing from the left to the right. So with this picture, we can actually obtain information as to whether this region is the deeper region or this region is the deeper region. We can tell. Right, I've taught you a very fast way to check. Right, just look at this distance, okay, between these two waves, these two wave fronts. Okay, we have a huge gap. Okay, imagine the huge gap to represent the distance between the water surface of a swimming pool and the bottom of the swimming pool. If you have a huge gap, it would imply this region would be deeper region. This one, the gap is so small. Imagine it as the distance between the water surface and the bottom of a swimming pool. Okay, only such a small gap that will tell us a shallow region. Shallow versus deep region. Describe the frequency of the water below the wave, making reference to wavelength, frequency, speed of the wave as it travels from the left to the right. Now, first thing I emphasize again, frequency of the wave does not change no matter if you are traveling from a deeper region to a shallow region or vice versa. Frequency remains unchanged. Wavelength, however, changes, and wavelength can be observed very obviously from the left to the right. Look at wavelength. Short wavelength, short, longer, 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 longest wavelength. Your wavelength increases. What about the speed? the speed always changes in the same direction as the wavelength. That means if wavelength increase, speed also increase. If wavelength decrease, speed also decrease. Alright, I think that's about all I want to cover. Let's see. Of course, maybe using this last question, you need to know if the wave, for this example, the wave is traveling from the left to the right, as indicated by the arrow here. What are the next movements of particle P, Q, R, and S? You have to know. So for example, very quickly, P is going to move upwards, Q is going to move downwards, R is going to move downwards, and S is going to move upwards. What if I have a point T at the peak here? It can only go downwards, right, in the next instant. Alright, that's all I want to cover, and good luck for your revision for the test.